Hello students, this is our tutorial. We are discussing about limit, continuity and differentiation. Now we continue the class. I have earlier discussed some important things to remember. You can see this, some important things to remember. Case 1 and case 2 are already discussed. Today we will discuss the case 3. Now case 3 can be happen in such a condition that fa and limit of fx extends to a both exist but unequal. It can a very important thing, very important. I have marked to start. Very important thing, the fa also exists and limit of fx also exists but are unequal. Now take an example. How can it be? Fx is equal to 0 when x is not equal to 0, greater than 0, either less than 0. But when x equal to 0, the value of fx is equal to 1. Such a function is defined in such a manner. Now easy to see that limit fx x tends to 0 plus means approaching 0 towards positive side. Its value will be of course 0, given 0 if x greater than 0, and limit of fx x tends to 0 minus, it means x approaches to 0 negative side of 0, x approaching to 0 negative side of the value 0, so its value will be 0. It means x is equal to less than 0, however near it is. Now we can see that limit right hand limit of fx and left hand limit of fx both are equal, so limit of fx at the point 0 exists and is equal to 0, and by definition of f0, if we put x equal to 0 we will get 1. Then limit fx, I have already proved that limit of fx at x tends to 0 is exist, and f0 is also a finite quantity, it also exists, but both have different values. That's why both are unequal. This is a very important case. You will have to remember this for improving your limit, continuity, differentiation parts. You need to remember this such kind of exceptional cases. Now we go to case 4. What can be? Neither fa nor limit fx x tends to a exist, nor fa exist, neither fa exist nor limit of fx at the point a exist. Let a example, fx is equal to sine 1 by x. Here it is clear that f0, if we will search the function's limit at the point 0, so we will first put x equal to 0, then it is undefined because sine 1 by 0, sine infinity 1 by x, its value will be sine infinity. 1 by x is actually undefined, so sine of undefined value is undefined, that's why it is undefined, so f0 does not exist. Now if we will check the check its limit function at 0, then we know that sine theta, mod of sine theta always belongs to -1 to 1, as we know from the science property that any angle of value of theta, sine always belongs to the sine of the angle always belongs to the -1 to 1. For every value of theta which can be take up to infinity, but sine theta always belongs to -1 to 1. Now take x equal to 1 by 2n plus 1 pi minus y, where y less than pi and n belongs to z. You take a snapshot, it's a very difficult case. Take a snapshot and try to understand it. What I'm trying to understand you, that 1 by x I will put 1 by 2n plus 1 pi minus y less than pi and n belongs to Z means any kind of integers, set of any kind of integer. Now look it, limit x fx x tends to 0 plus means x approaching to 0 from the positive side. Then sign will be, if we replace x value here, then it will become sine of 2n plus 1 pi minus y, which will we get plus sine y. You can, if you know the trigonometry property in senior level, you can very easily calculate it. It will be plus sine y, where y less than pi. And if you take x equal to 1 by 2n pi minus y, where y less than pi and n belongs to any set of integer, then we'll get limit of fx x tends to 0 minus it means approaches to 0 from the negative side, and we replace the to the function fx sine 1 by x, then we'll get that sine 2n pi minus y, which will be minus sine y, where y less than pi. So it is clear that left hand limit of fx and right hand limit of fx are not equal. So fx also does not exist. So if it does not exist, f0 does not exist means at the point 0, and also at the point 0 the limit also does not exist. So it is also very important and exceptional case 1. So you have to remember this. And today we will discuss more one thing, very important. I think that it is a fundamental tool to understand limit. Cauchy necessary and sufficient condition for the existence of limit. The necessary and sufficient condition that the any limit at any point exists and is finite. Its value will be finite, not a infinity value. Is that corresponding to any very small positive number epsilon, not equal to 0, of course, very small but not equal to 0. We can find a positive number delta which is also very small but not equal to 0, such that x1 for any x1 and x2 being any two quantity or any 2 points must satisfy the first condition is must satisfy 0 less than mod of x minus a less than or equal to delta. Means if you draw a circle, a closed circle means the x take any value in interior of this circle and also boundary points of the circle. So it is called closed circle. So where A is the A is situated at the center, and delta is radius, and x can be any value of the interior or the boundary point. So such kind of condition if it holds, then it must be fulfilled that mod of fx1 minus fx2 mod of course less than epsilon. If such kind if it is satisfied, then it must be fulfilled that if fx1 and fx2 less than epsilon. It is also very important thing to understand. The two condition also satisfied. One condition if satisfied, then the other condition must be satisfied. So this Cauchy's necessary sufficient condition for existence of limit means any point you take x tends to a, if you take in the neighborhood of a any point x1 and x2 very nearly to the delta is very small. I have already said delta is very small but not equal to 0, and x1 x2 very nearly to a, then such a condition if you satisfy, then for existence of the limit it is necessary that it must necessary to fulfill that fx1 minus mod of fx1 minus fx2 less than epsilon. Note that how can you understand this? Draw a circle where fx1 at the put at the center and fx2 at another point interior of the circle, where epsilon is the epsilon is an open circle, less than it means open circle. So fx2 must belongs to the not on the boundary but in the interior of the circle. So fx2 in the interior of the circle. So the subtraction between the values of fx1 and fx2 must less than epsilon. So this is what is its meaning. It means that this circle is a 2D figure. It can be put in 3D figure also. So 2D figure is necessary to understand, and then you can understand also 3D figures also. So both are given in to understand you in 2D figure also as well as 3D figure. Try to understand this and take a snapshot to understand better way. I am giving it to you in a good mode just so that you can take a snapshot. Take a snapshot in this manner that you can study it very good way. now today we finish limit. Limit is already finished. We'll discuss next day the other properties of limit if it remains, and the other properties also continue to will start, and then differentiation also. So also thanks to all of you, and of course it is very important for students BSc, MSc, SET, NET and joint entrance engineering courses students. So very faithfully you can go through this study and get the benefit. Thank you, and of course please subscribe the channel. I will lodge continued videos related to this topic, differentiation, limit and continuity, and the beneficial points which are commonly ignored by students. I must discuss, and I'll try to catch your attention on those points. Thank you, and subscribe please this channel and share with your friends. It is my request. Thank you.